And we have we have an NADH, and we have an oxaloacetate. Okay? Just like it says on the board. On the intermembrane, in the matrix, we have an NAD+, we have an alpha-ketoglutarate, and we have an aspartate. Okay, now, first reaction. We have this oxidation of oxaloacetate, so it gives up, we have a reduction of oxaloacetate by the NADH out here in the cytosol. So when it gets reduced, it goes to malate, and when it gets oxidized, it goes to NAD+. Okay? Okay, we're good. Then we get this freebie transport across. So the glutamate, pay attention glutamate, you cross while the aspartate comes out. So the glutamate comes in, the aspartate comes out. Also, the alpha-ketoglutarate, which is on the inside, comes out at the same time that the malate goes in. Okay? Okay, it's all a freebie. And they're just crossing, it's an antiporter. Now the oxaloacetate, the malate goes in here, now gives its electrons up on the inside, reverting back to oxaloacetate. And the electrons go to NAD to make NADH. Yes, you're key. Now the transaminase comes in, and the amino group on the glutamate is transferred to the oxaloacetate, leaving alpha-ketoglutarate, and the oxaloacetate becomes aspartate, the transaminase. In the meantime, out in the cytosol, the aspartate gives up its amino group, leaving oxaloacetate, donates it to the alpha-ketoglutarate, which generates glutamate, the amino acid. Now, when we started all this, we had glutamate, there's the glutamate on the outside. We had oxaloacetate on the outside. There it is. We had NADH on the outside. Whoop. Now we have NAD. When we started all this on the inside, we had aspartate, there it is. We had alpha-ketoglutarate, there it is. But instead of NAD+, we have NADH. So it's different from when we started. So what has been the consequence of all this nonsense? The NADH, which used to be out here, where it can't make ATP or do anything else but gum things up and get in the way, is now those electrons are in here in the matrix where we can use the NADH to make ATP. And that's the whole point of the malate aspartate shuttle. So what I want you to remember is not all these details, so you guys aren't missing anything by not writing it down. Not all the details, but the bottom line, which is the point of the malate aspartate shuttle, is that number one is to get electrons, it's essentially to effectively move those electrons from NADH in the cytoplasm to NADH, to NAD to make NADH in the matrix. And that it's a freebie. It hasn't cost us anything because of all this, if you rearrange the amine transfers and so on, in terms of organic compounds, we're back to where we started. Okay, thanks guys.